The following Zoom session, my voice is in great form today. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. Alrighty, so today we're going to go on to section 5.6. But first, are there any questions from any of you concerning homework over the weekend? If so, now
could you review that question about the apartment building and finding like the length of the bedroom?
Okay. So let's see here. Okay. Let's get into WebAssign. And okay, give me just a minute here. Let's see. Okay. So this is from 5.5, I assume. And bedroom. Aha. So problem number 20.
Yeah, that's the one.
Okay. Let's take a look at this one here. Okay. So it says, consider the following drawing. So you've got A of X, B of X, C of X, and D of X. And then it tells you what A of X, B of X, C of X, and D of X are supposed to be. It says, what is the difference in the length and width of the one-bedroom apartment shown? Okay, so they want the whole thing. So the length would be A of X plus B of X, length. But A of X is X squared minus X plus 4. So we've got X squared minus X plus 4, all of that, plus B of X, which is 8X plus 5. And then the width is C of X, which is X squared minus 14X plus 3, plus D of X, which is 7X plus 4. Okay, so let's go back to the whiteboard screen. So the length was A of X plus B of X, which is what I've got written up there. And then the width was what's written there as well. Okay, so let's take a look at the length. We could rewrite this as X squared minus X plus 4 plus 8X plus 5, which combining like terms would be X squared plus 7X plus 9. So there's the total length adding together A of X and B of X, okay? Then the width would be X squared minus 14X plus 3 plus 7X plus 4, which is X squared minus 7X plus 7. Okay, so now we've got the length and the width, and it says, find what is the difference in the length and width. So we're going to take the length minus the width. And I've got to put parentheses around the width because I'm subtracting that whole thing each and every turn. So then I get term, that is not turn, X squared plus 7X plus 9 minus X squared minus, oh wait, that's going to be plus because it's minus times minus, plus 7X minus 7, which is, which is I've done something wrong. Oh, no, I see what I did wrong. It's plus 7X plus 7X, so it's 14X plus 2. So that would be the difference of the length and the width. Are you okay with that, how I got that?
Yeah, I see what I did wrong.
Okay. Then it says find the perimeter. So the perimeter would be 2 times the length plus 2 times the width, which is going to be 2x squared plus 14x plus 18 plus 2x squared minus 14x plus 14. Let's see, combining like terms. Now we're going to cross those out. We're going to get 4x squared plus 32. And that's going to be feet as well. All righty. Any other questions, anybody from homework over the weekend? Okay, then we shall get out of there and let's take a look at section 5.6. All right, so we've looked at adding and subtracting polynomials. Next, we're going to look at multiplying and then eventually dividing polynomials. So let's start off with just multiplying some monomials together. Let's say I've got 5m times m. That would be 5m squared. Let's say I've got negative 2a cubed times 11a squared. That would be negative 22a to the 5th power. Any questions there? All right, let's say I've got 3y times 7y squared times negative y to the 4th. That would be negative 21y to the 7th. Don't forget there's an implied 1 there, just like there's an implied 1 there, an implied 1 there in terms of exponents. All right, we good on that? Let's say we've got this situation. We've got 3a times the quantity a plus 2. So now we're going to distribute the 3a. Let's see here, move that back over there. So we get 3a squared plus 6a. I can't go any further because a squared and a are not like terms. Let's say I've got negative 4b cubed times the quantity 2b squared minus 2b plus 2. So distributing, we get negative 8b to the 5th plus 8b to the 4th minus 8b cubed. Again, any questions there? All right. Now, let's say we've got y times y plus 5 plus 3 times y plus 5. Okay. So we're going to distribute y through the first binomial. We get y squared plus 5y. Then we're going to distribute the 3 through the second binomial, 3y plus 15. And this would be a plus 3y. So now we've got that. Then combining like terms, we get y squared plus 8y plus 15. Any questions about what I just did? All right. Now we're going to take y plus 3 times y plus 5. So instead of multiplying y times this and then plus 3 times that, I'm going to combine it. But I'm actually going to do the same thing as I did in the previous frame. I'm going to take y times y, which is y squared, and then y times 5, which is plus 5y. And then now that I've multiplied this by everything over there, I'll move over to the next term. Y times 3, or 3 times y, is 3y, plus 3 times 5 is 15. Combining like terms, I get y squared plus 8y plus 15. So I multiplied two binomials together, and in this case, I got a resulting trinomial. This process is called FOIL, and it stands for first, outer, inner, and last. Okay, so we took the first times the first, that's where we got the y squared. Then we did the outer ones, the y times the plus 5. Then we did the inner ones, the 3 times the y, and then the last ones, 3 times 5 is 15. So they call this FOIL. It's multiplying polynomials together, but specifically for this case, FOIL. All right, let's take a look at another example. Let's take a plus 4 times a plus 5. So we're going to take the first times the first. A times a is a squared. Then we're going to do the outer ones. A times 5 is 5a. The inner ones, 4 times a is 4a. And the last ones, 4 times 5 is 20. Then combining like terms, a squared plus 9a plus 20. So there's our resulting product. Again, any questions on the process? All righty, let's see here. We're going to take n plus 8 times n minus 10. So n times n is n squared. N times minus 10 is minus 10n. 8 times n is 8n. And 8 times minus 10 is minus 80. Combining like terms, n squared minus 2n minus 80. All right, let's take another look here. Let's see, how about 5x minus 3 times 2x minus 3. So we get 10x squared minus 15x minus 6x plus 9. Combining like terms, 10x squared minus 21x plus 9. Again, any questions? All right, let's take a look at some examples with decimals. 2.6x minus 3 times 2x minus 1. So we've got 2.6x times 2. 2 times 2.6 would be 5.2, and x times x is x squared. All right. Then 2.6x times minus 1 is minus 2.6x. Minus 3 times 2x is minus 6x. And minus 3 times minus 1 is plus 3. Combining like terms, 5.2x squared minus 2.6x minus 6 more x would be minus 8.6x, and then plus 3. All righty. Let's do one with some fractions in it. If I'm going too fast, let me know. I can slow down. 8t minus a half times 4t minus 5/2. Oh, I know what I wanted to say to the group and hopefully get it to where everybody that watches this gets the idea. So I've been noticing some of you have been having an issue with organizing your time and stuff. And what I wanted to mention was that, okay, so for instance, today's homework assignment, this is Monday, and I realize that this homework assignment doesn't have to be finished until tomorrow at 11:59 p.m. The problem is, if you wait till tomorrow, especially if you wait till tomorrow late evening to do the assignment, you might run out of time. Or maybe you procrastinate, don't do it today, and you wait till tomorrow, and then something comes up and you can't get it done. The idea isn't to wait until the next day. You should be working on it today, trying to get it finished as much as possible. And then if you still have questions, you can ask them tomorrow during class so that you can wrap it up by tomorrow night. But some of you are putting it off until the last minute, and consequently, things aren't working out well for you. So I want you to think about how you're organizing your time for your homework. Okay, enough nagging, back to the main thing here. All right. 8t times 4t is 32t squared. 8t times minus half, or minus 5/2, excuse me. Well, it's going to be minus, let's see, 8t times negative 5/2. The 8 and the 2 would reduce down to 4/1, so I'm going to get what, minus 20t. Okay. And then minus 1/2 times 4t is going to be minus, let's see, minus 1/2 times 4t. 4/2 reduces to 2/1, so minus 2t. And then minus 1/2 times minus 5/2. Negative times negative, or minus times minus, is going to be a plus. So that's going to be plus 5/4. Okay, because when you're multiplying fractions, you multiply straight across. Combining like terms, I'm going to get 32t squared minus 22t plus 5/4. All righty. How about this one? S cubed minus 6 times s cubed minus 8. So now we've got s cubed times s cubed would be s to the 6th power. S cubed times minus 8 is minus 8s cubed. Minus 6 times s cubed is minus 6s cubed. And minus 6 times minus 8 is a plus 48. Combining like terms, s to the 6th minus 14s cubed plus 48. Write that a little neater here. All right. Now we're going to expand our horizons a bit, and instead of multiplying a binomial times a binomial, we're going to multiply a binomial times a trinomial. Now, FOIL only has 4 letters for 4 multiplications, so we can't really spell out FOIL during this, doing this particular problem, but we can use the same idea, and that is we'll start with the first term in the first polynomial, and we'll multiply it by each term in the second polynomial. So we're going to get x times x squared is x cubed. X times minus 2x is minus 2x squared. And x times a plus 3 is plus 3x. Now that I've exhausted all of the combinations of that first term in the first polynomial by each term in the second polynomial, I'll move over to the second term in the first polynomial. And I'll take 2 times x squared, which is 2x squared, 2 times minus 2x, which is minus 4x, and 2 times 3, which is 6. So I actually end up with 6 products, not just 4. I'm going to combine like terms, and I'm going to put them in descending powers of the variable. So x cubed, the x squareds will cancel. 3x minus 4x is minus x, and then plus 6. So there's my result. Any questions about that process? Okay, let's take another binomial times a
I have a quick
trinomial.
question for the last one.
Yeah.
In were you the result of it equaling negative x or 3x minus x, would it still accept it if you put minus 1x, or do you just cancel out the one altogether?
It isn't wrong to have the one coefficient there. Is that what you're talking about?
Yes.
But I think in WebAssign, it doesn't recognize it. It wants you to leave it off. And
Okay.
most people would say, you know, it isn't wrong to have the one there, but it's not necessary. Just like it
Yeah.
could be.
I just want to know what WebAssign would expect.
Yeah, I believe they don't like that one coefficient there.
Okay. Thank you.
You betcha. All right, let's see here. Back to this one. Okay, 2x squared minus 3x plus 1. So we're going to get 6x cubed minus 9x squared plus 3x. So I've taken the 3x times everything in the second polynomial now, plus 1 times 2x squared, plus 1 times minus 3x is minus 3x, and plus 1 times plus 1 is plus 1. Combining like terms, 6x cubed minus 7x squared, those cancel, then plus 1. Okay. Any questions there? All right, let's take a trinomial times a trinomial. So we've got r squared minus r plus 3 times r squared minus 4r minus 5. So now we're going to have 9 products. R squared times r squared is r to the 4th power. R squared times minus 4r is minus 4r cubed. R squared times minus 5 is minus 5r squared. So then moving over to the next term there, we get minus r times r squared is minus r cubed. Minus r times minus 4r is plus 4r squared. Remember, minus times minus is plus. Minus r times minus 5 is plus 5r. And we're going to move over to the next term. 3 times r squared is plus 3r squared. 3 times minus 4r is minus 12r. 3 times minus 5 is minus 15. Combining like terms, we're going to get r to the 4th. Let's see, minus 4r squared minus r squared would be cubed. Minus 4r cubed minus r cubed is minus 5r cubed. Then we've got minus 5r squared plus 4r squared plus 3r squared. So minus 5 plus 4 is minus 1. Minus 1 plus 3 is plus 2. So I've got plus 2r squared. And then 5r minus 12r is minus 7r. And finally, minus 15. Okay. Any questions there? All right, now we're going to look at multiplication instead of horizontally, vertically. X squared minus 2x plus 1 times x plus 2. So we're going to multiply. That's going to be an x multiplication symbol. All right, so 2 times 1 is 2. 2 times minus 2x would be minus 4x, and 2 times x squared would be 2x squared. Okay, x times 1 would be x times minus 2x would be minus 2x squared, and x times x squared is x cubed. Let's see, this was a plus, and then adding up the result, 2 minus 3x, we've got to have a plus there, and then x cubed. So x cubed minus 3x plus 2. I don't know about you, but I much prefer the horizontal method, because here you kind of have to remember to, to put signs in front of things and everything, but it can be done. This is actually a closer model to arithmetic multiplication than doing it horizontally. In other words, like if you take 324 times 73, you don't do it this way. You end up lining it up like that, all right? So anyway, now we're going to multiply 3 polynomials together. So I've got 4x, that's technically a monomial, 4x times 2x plus 1 times x minus 2. Now, we can only multiply 2 of those factors together at once. So we're going to get 8x squared plus 4x. Then we're going to take the results times the last binomial. So then we get 8x cubed minus 16x squared plus 4x squared minus 8x, which is 8x cubed minus 12x squared minus 8x. Any questions there? All right. Let's see. How about this one? Negative 2a squared times negative 3a cubed times 3a minus 2. Now, multiplying these first 2 factors, those are monomials, so we're just going to get 6a to the 5th. Then we're going to distribute that to that resulting binomial. So we're going to get 18a to the 6th minus 12a to the 5th. And now let's take a binomial times a binomial times a binomial. X minus 4 times x plus 1 times x minus 3. So we're going to multiply the first 2 together, order of operations multiplication from left to right. So that's going to give us x squared plus x minus 4x minus 4. But combining like terms, we get x squared minus 3x minus 4. And then that's going to get multiplied by that last binomial. So we've got x cubed minus 3x squared minus 3x squared plus 9x minus 4x plus 12. X cubed minus 6x squared plus 5x plus 12. Okay, let's see here. All right. This is 4 times x plus 7 times x minus 6. So we're going to distribute the 4 to the first binomial, 4x plus 28, then take the results and distribute it or FOIL it to the next binomial, 4x squared minus 24x plus 28x minus, let's see, 168. So 4x squared plus 4x minus 168. 68. Okay, let's see here. Let's take a look at some lookalikes, as they are called. So we've got, let's see, where did it go? This. So part A and part B. Part A is x minus 2 plus x squared plus 2x plus 4. Part B is x minus 2 times x squared plus 2x plus 4. I want to point out that a common mistake that students make on a test is they'll take something like this first thing and they'll do it like the second thing. They sort of ignore that plus sign and they see two polynomials and they just start foiling them and multiplying them together. Be very careful. We're not multiplying in that first problem, we're adding. So this is x minus 2 plus x squared plus 2x plus 4, which is x squared plus 3x plus 2, combining like terms. All right, the second one we are multiplying, so we get x cubed plus 2x squared plus 4x minus 2x squared minus 4x minus 8, which is x cubed. The x squareds cancel, the x's cancel, and we get minus 8. A binomial times a trinomial, and we get back to a binomial. That doesn't always happen. These are just special cases. But again, pay close attention to the operation. Let's see here. How about this one? We've got, let's see, negative 5r to the 4th t squared r to the 4th t squared minus 2r squared t, and then over here part B is negative 5r to the 4th t squared times 2r squared t. So in the first problem, we're going to get negative 5r to the 4th t squared minus 2r squared t. There are no like terms, so we can't really simplify it any further. Second one, we're going to multiply, but this is just a monomial times a monomial, so we're not distributing. We're going to get negative 10 r to the 6th t cubed. But again, pay attention to the operation. Okay, let's see here. How about this one? 1/2 c minus 3d plus 3/4 c plus d. Okay, so we're adding. We're going to have what? 1/2 c minus 3d plus 3/4 c plus d. These are like terms. I'm going to put them next to each other. These are like terms. I'm going to put those next to each other. But to combine those first two like terms, I need a common denominator. What's the least common denominator of 2 and 4? Anybody?
Is it 2? 4.
It's a 4. So that ain't broke, don't fix it. We're going to have to multiply this by 2 over 2 to get 2/4. Okay? So now I've got 2/4 C plus 3/4 C, which is 5/4 C. And then plus, oh, not plus, minus 2D. Also in WebAssign, don't use a mixed number. In fact, typically just even using it, writing stuff out on paper, you don't normally see 1 1/4 C. You don't normally see C, whatever. You could have 1.25 C or 5/4 C, but they don't tend to use mixed numbers as coefficients. Okay, doesn't mean it's wrong, it's just not preferred. And in WebAssign, I don't think it'll work. All right. Now let's take this situation, 1/2 C minus 3D times 3/4 C plus D. So we're going to take 1/2 C times 3/4 C, which is what? 3/8 C squared. And then 1/2 C times D would be plus 1/2 CD. Minus 3D times 3/4 C would be not minus 9/4 CD. And minus 3D times plus D is minus 3D squared. Now, the middle two terms are like terms. And again, our least common denominator is a 4. So I'm going to multiply 1/2 by 2/2 to get 2/4. So 1/2 is equal to 2/4. Okay. Combining like terms, 3/8 C squared minus 7/4 CD minus 3 D squared. So again, pay close attention to the operations. Okay.
Will you leave that up for just a second?
I will leave it up there even longer if you'd like.
Okay, got it. Thank you.
You're welcome. All right. This next one, we've got a postage stamp. And the dimensions, here it says 29. Boy, this is an old stamp. And then there's a picture and a bunch of stuff there. Anyway, its length is 3x minus 1 centimeters. Its height is 2x plus 1 centimeters. All right. And we want to find the polynomial that represents the area of the stamp. So the area is length times width. So the area would be 3x minus 1 centimeters times 2x plus 1 centimeters. I'm going to rewrite that without the centimeter units there. But in fact, the final answer would have what? Square centimeters? Okay. So now I'm going to get 6x squared plus 3x minus 2x minus 1 square centimeters, which is 6x squared plus x minus 1 square centimeters. And again, I need parentheses around that whole polynomial because the units of square centimeters goes with the whole quantity. All righty. Well, that's all I've got for you today. So again, this is section 5.6 for tonight. And I'll be back at 1:15 with an office hour if you have any questions. I'm going to go ahead and stop the recording. And